be a very quick video introducing the pumping lemma for context-free languages. This is simply an intro to the pumping lemma for context-free languages. Tracy will cover the pumping lemma in more detail when she returns next week. I am simply going to state the theorem and provide a simple example. For L, an infinite context-free language, there exists some positive integer m such that any word W in L, such that the length of W is greater than or equal to m, W can be decomposed. It can be decomposed as U, V, X, Y, Z, where there are 5 substrings of W. There are some requirements of these substrings. V, X, Y together cannot be longer than m, and V and Y together have to be greater than or equal to 1 in length, meaning both substrings cannot be empty. If all of these things are met, then U, V to the I, X, Y to the I, Z is in L for all I. What does this really mean? It means there's a cycle in our grammar, or there's a cycle in our NPDA. Just like the pumping lemma for regular languages, there has to be a cycle in order to have an infinite language, because the automata itself is finite. We're going to go through an example. From the last video, I used this example to show that context-free languages are not closed under intersection, because this is not a context-free language. But I told you to suspend disbelief until we talked about the pumping lemma to show that this is not context-free. I'm going to show it now. I'm sure Tracy will go over it in more detail when she covers the pumping lemma a little more thoroughly. So in this example, we're going to show that the language L equals A to the n, B to the n, C to the n, where n is greater than or equal to 0, is not context-free. So what we do here is a proof by contradiction. So we assume that it is, and we allow an adversary to choose some m. Once they've chosen m, we actually pick the string A to the m, B to the m, C to the m. This string is in L. Now, the job of the adversary is to find a substring and pump it up or down to show that it's not in the language. If you can pump it up or down and not get a word in the language, then this language is not context-free. Our adversary has several choices in order to pump a substring out of the language. First is we can choose the substring VXY, and we can say that it contains only A's. As a reminder, this is the substring that we're dealing with, right? This is our word broken down into substrings. And we're under the assumption that U, V to the I, X, Y to the I, Z is in L, right? So pumping this substring up keeps this word in the language. If we choose only A's, then all we have to do is choose I equals 2, and all of a sudden the word is not in L, because now you have more A's than you had B's, than you have C's. Another option for the adversary is to choose VXY that contains an equal number of A's and B's. In this situation, again, you can choose I equals 2, and you will get that the word has been pumped out of the language, because you'll get A to the K, B to the K, C to the M, where K and M are not equal. In fact, this is true if you have VXY being equal number of B's and C's. The same is true. So it seems like the only thing the adversary can try to do to keep it in the language is to choose an equal number of A's, B's, and C's. The only problem here is that this isn't allowed, because the length of V, X, and Y has to be less than or equal to M. And in order to choose an equal number of A's, B's, and C's out of the word A to the M, B to the M, C to the M, there has to be an equal number equaling M. So in order to choose a substring of A to the M, B to the M, C to the M that has an equal number of A's, B's, and C's, you have the entirety of all the B's in there, which means that the length of your substring is equal to M without any A's or C's in it. So this isn't even allowed. So this choice of substring isn't even allowed. Therefore, we've exhausted all of our options. And every time we choose a substring and we pump it up or pump it down, the word is no longer in the language. Therefore, L is not context-free. This has been a very quick, simple introduction to the pumping lemma for context-free languages. Again, this will be covered in more detail when Tracy returns next week. I'm sure you'll go through the proof as well as more examples. But now you have an understanding of why A to the N, B to the N, C to the N is not context-free, and now you probably have a better understanding of why context-free languages are not closed under intersection.